Hi everyone, welcome to my channel, Tutorlini Test Prep. Today I will be providing a full walkthrough of the Digital SAT Math Linear SAT Test Unique number 5. Quick disclaimer, this video will cover the linear, non-adaptive SAT practice tests found on College Board's website. Many of the questions from these tests are duplicated in the Bluebook app, which I've already covered in previous videos. This video will only cover the unique questions, so there are no repeats. A link to the Linear Test Unique PDFs will be in the description. I highly recommend you complete the questions yourself before watching this video. Let's get started. Okay, this is Module 1, question number 2. So, we could make a linear equation for this problem, but we really don't have to. It just wants us to track this film club over the course of the first couple of days. What I like to do when I see a problem like this, where I know I'm not going to have to go that far into the future, is to just make a table. So the question tells me on the first day that there are 90 members, so I'm going to put 90. And then it says 10 new members join every day after the first day. So that means on the second day, I'll add 10, which is 100. On the third day, we'll add 10, which is 110. And then on the fourth day, we'll have another 10, which is 120. And on the fifth day, we'll have 130. So kind of confusing. It says 4 days after the first day of the first semester. So that is really the fifth day. I don't know why they said that like that. But anyway, I think the answer is 130, which is answer choice B. Great. Okay, Module 1, question number 3. So this question wants us to find the y-intercept of the graph. So we're going to see wherever the graph touches the y-axis. I see it's right here, so I'm going to circle it. And that is x is 0, y is 8. And that is answer choice D. Great, let's keep going. Okay, Module 1, question number 4. So this is just a system of equations. We already have one of the values, so I can just substitute it straight into the other equation. So that's going to look like this. S plus 7 times 3 equals 27. We get S, 7 times 3 is 21. And now I'm going to subtract 21 from both sides. And we should get S is 6. So R is 3 and S is 6. So the ordered pair should be 3, 6, which is answer choice B. And that is correct. Probably not that helpful for this question, but for a future one, if you see it like that, something you can do that helps a ton on harder questions is changing the letters to X and Y. So if I do X plus 7Y equals 27 and Y equals 3, you could use that to check your answer really quickly. The only thing is the way I defined it doesn't line up with how they define it. So I really should redo this. So give me a sec. So S is in the second spot. So we're going to do Y. So Y plus 7X equals 27. See, I made a tiny mistake there. They said R is X. X equals 3. And we get 3, 6. Again, not that helpful for this one, but could be helpful for a future question. Let's keep going. Okay, Module 1, question number 5. So we're given a table and we're trying to figure out if it's linear, exponential, etc. So when you're doing this by hand, all you're looking for to tell if a function is linear or exponential is you're looking for what's called a constant rate of change. So when x changes by some fixed amount, in this case it's going up by 1 constantly, we're seeing if y changes by a fixed amount as well. It doesn't have to be the same amount as the x's, but it has to be the same amount for each y when we change x by that much. So you see, each time we move x up by 1, y goes up by 1. So it's going up by a fixed amount. So it has a constant rate of change. So that means it's linear. So we're right away going to cross off anything that says exponential. So C and D are out. And increasing, decreasing, that just means as you go left to right, as x gets bigger, is it going up or is it going down? You see, as x gets bigger, y is getting bigger as well, 16, 17, 18, 19. So since y is getting bigger as x gets bigger, we say that that is increasing. If y were getting smaller as x gets bigger, we would say it's decreasing. So I believe the answer is answer choice B. And that is correct. We could also plot this on Desmos, and why not, just for the heck of it, we find the equation really quickly. So I'm going to make a table, and I'm going to do -1, 16, 0, 17, 1, 18, 2, 19. And you can already kind of see that that's in a straight line, right? But just in case you weren't sure, I'm going to regress. And they tell me the slope is 1 and b is 17. So I'm going to do y equals 1x plus 17. And certainly it looks like that line perfectly goes through those points. Exponential graph would give us a curve, not a line. Great, let's keep going. Okay, this is module 1, question number 24. So there would be no reason to do this without making a picture, but I am going to go over how to do it by hand first, just for the heck of it. So the concept you really want to understand here is that when you have a times b to the x, that's the most basic form of an exponential function. You see sometimes, like in option 1, we have this horizontal shift, which we call c. So sometimes it's plus c, but sometimes it isn't. A lot of times they just give you a b to the x. So we have what's called growth and decay. Growth looks like this. Decay looks like this. Growth happens when b is greater than 1. And decay happens when 0 is less than b is less than 1. And when there is a negative in front of the function, when a is negative, then these guys get reflected over the x-axis. So watch, they get kind of flipped upside down. So negative growth, quote unquote, looks like that. And negative decay looks like that. See how they're like mirror images of each other? You take the other one and you just kind of flip it over. So it seems like I'm looking at both these answer choices. Both of these have b greater than 1, so they're both growth, and they both have a negative in front. So these guys are both the negative growth I was describing. Again, it's neither here nor there, because you see, guys, these graphs, they hug asymptotes. So unless you restrict the domain, they don't have a minimum or a maximum. And this question didn't say anything about restricting the domain. So there is no minimum or maximum. So the answer is D. Neither of them have a min or max. Anyway, let's look at Desmos. If you want to look at those questions about restricting the domain, watch my Desmos lesson number 17. It talks about that. But this one did not restrict the domain. I'll try to maybe briefly show you guys what I mean. So I'm going to do f of x equals -6, 3 to the x minus 3. And you can see, guys, that there's definitely no minimum. It goes down forever, right? So there's definitely no minimum. And it might look like there's a maximum, but there isn't really a maximum either. This is asymptotically getting closer and closer to -3, but it's never going to hit it. So it doesn't quite have a maximum either. Again, don't worry, the SAT wouldn't ask you about that. It's kind of a advanced math concept. Anyway, so they just want you to realize that it goes down forever, so it doesn't have a minimum. Okay, let's look at g of x. Okay, we see the same thing, goes down forever. It looks like it has a max of 0, but that's a horizontal asymptote, so it's getting very, very close to 0 and never touching it. Again, goes down forever. If, let's say, guys, so that's it, that's the answer, neither 1 nor 2. If, let's say, they said, oh, when x is less than or equal to 4 or something, right? Then there would be a minimum. You see it, we kind of stop it right there. That would be the smallest value, right? That's the lowest point on the graph for sure. But because this question wants us to look at all real numbers for x, exponentials, unless you cut them off somewhere, they don't have min or max. Quadratics, which are on the SAT a lot, have min or max. Exponentials do not, unless you just look at a piece of it. Great, let's keep going. Okay, this is module 2, question number 2. Once again, I don't really think there's much we do for this one. I think they just want us to read the graph. So it says temperature is 600 kelvins. Okay, temperature is the x-axis. That's right here. So I'm going to see where that reads the graph, and then I'll come over here and read the pressure. Certainly seems like it's at about 12 psi. So I'm going to go with answer choice B, which is correct. Great, let's move on. Okay, this is module 2, question number 4. Guys, I went over this in my Ottocento, I believe it's number 4 on factoring. So definitely check that out. If you haven't already, I go over this exact concept. The question's not super clear, but it wants us to factor the GCF. So the GCF, the greatest common factor of 16 and 14, is 2. So I'm going to pull out a 2. The highest power of x that goes in, well, this one has 3 x's, this one has 1. So the highest power they both have is x to the 1. And then the y's, this one has 2, this one has 1. So the highest power of y they both have is, again, y to the 1, or just y. Now what we do is we divide both of these by the GCF to see what's left. 16 divided by 2 is 8, and then x cubed divided by x is x squared. Y squared divided by y is y. 14 divided by 2 is 7. And then these guys just kind of go away. X divided by x is 1, y divided by y is 1. So we get 2xy times parentheses 8x squared y plus 7. And that is answer choice B. I suppose you could come up with random numbers and guess and check, but that would probably take way longer. You definitely want to learn this. Factoring out the GCF, factoring by pulling out a GCF, it comes up a lot on the exam. One last thing I guess I'll mention, I mentioned this in the Ottocento video as well, is if you're having trouble seeing greatest common factor, at least the numerical portion, there is a command on Desmos for it. So you see I type in GCD 16, 14, it's 2. So definitely if you're ever having trouble finding a least common multiple, so for example, least common multiple of 3 and 5, a greatest common factor or greatest common divisor, GCD, or an LCM, you can just type in like as many numbers as you want, I think, and it should be able to find it for you. So that can be helpful in a pinch. Great, let's keep going. Okay, this is module 2, question number 9. Before we do this one, there's some outside knowledge that you should probably know by heart. I've gone over in many of my videos at this point. I'll pull it up on the board right now. Give me 1 second. Okay, so this is how most projectile quadratics problems shake out. This is what they expect you to understand. The y-intercept, which we call lowercase c when we're doing quadratics, is the initial height. The positive x-intercept is the time it takes to reach the ground. And the vertex, which we call h comma k, h is the time it takes to reach the max height, and k is the max height. So this shows up a lot. I would pause this video and write this down. Make sure you know this chart forwards and backwards. Let's go back to the question. Okay, so this question is asking for the interpretation of the x-intercept. That's right here. We just talked about that. As we talked about the positive x-intercept, I didn't even read the question. The positive x-intercept is the time it takes for the projectile to hit the ground. So we're going to look for an answer choice that sounds kind of like that. First of all, it says, I see the numbers between 1 and 2, like 1.5, 1.6, 1.7. Any answer choice that just has the wrong number is wrong. So C and D, I don't even need to read. I know they're wrong. Okay. So now we're between A and B. Do we want the diver reaches a maximum height? No. No, that is talking about the vertex. That is talking about this point, or it's trying to talk about max height we get from the y-coordinate of the vertex. So that is not right. Okay, so A's out. I guess it's got to be B. Let's see what sounds good about B. We got 1.6 seconds. That's good. And the diver hits the water. That sounds very similar to the interpretation we did in the notes, which is that it's whenever the object reaches the ground, the time it takes for the object to reach the ground or come back down. Great. So C and D straight up do not have the right numbers. And A is talking about maximum height, which we wouldn't get from the vertex. We wouldn't get from the x-intercept. We would get that from the vertex. Great. Let's move on. Okay, this is module 2, question number 10. So, whenever you see function notation, guys, the letter on the inside is your x, and the letter on the outside is your y. So when you see k, and I'm going to do all this without even looking at the answer choices. Watch what I do. Don't even need to look at the answer choices. You should come up with your own answer in your own words before looking at the answer choices. That'll increase the chance of you getting it right. Okay, so look, guys, whatever letter is inside the parentheses goes here. So this one is V, and the number on the other side, when you interpret a point, is the letter on the outside. So this is K. So I'm going to color code this. Take a second to appreciate this, because you could totally see this question again. So if you knew how to read function notation, we just very quickly figured out that when V equals 34, K is equal to 5202. Okay, so now let's put this into words using the paragraph. When V equals 34, K is the speed in meters per second. Okay, let's write that down. Meters per second. I suppose I should keep the color coding consistent. How about I do that? And then it says the kinetic energy in joules is given by the function K. All right, so K is equal to 5202 joules. All right, that took a little bit, but now that we have all that, I'm very confident I'm going to get it right. So A, 34 meters per second, 5202 joules. Okay, I mean, that seems right off the bat. I do think it's A. Let's see what's wrong with the other answer choices. 340 meters per second. No idea where that's coming from. That wasn't in the point at all, so that's wrong. 5202 meters per second. This would be like if you mixed up x and y. So don't do that, guys. Follow the color coding I just showed you. The thing inside the number inside the parentheses is the letter inside the parentheses, and the number not in the parentheses is the letter not in the parentheses. And this number, I just have no idea where this came from. This is probably like if you plugged it in or something. I don't know. You don't have to do any math. This equation is just to kind of distract you. All they want you to do is to interpret this point based on the first part of the sentence, of the first sentence. Okay, so B and D have the wrong numbers, and C mixed up K and V. Great, let's keep going. Okay, this is module 2, question number 11, another one with not a lot of calculation. So in case you didn't know, guys, for a scatter plot with a line of best fit, the actual y values we get from the dots, and the predicted y values we get from the line. So I'm just going to really quickly, these are the actual, this is where you would read for the actual y values. And then this is where you would read for the predicted y values. So just make sure you understand that. So if the question's asking about the line of best fit or predicted y value, you look at the line itself. Okay, anyway, so it says we want the y value, we want the actual y value greater than the predicted y value. Okay, so let me write that down. Actual greater than predicted. So what I do is, guys, before I interpret, I always make sure actual is on the left-hand side. If actual were not on the left-hand side, I would flip the inequality around. Like, so if it said like predicted greater than actual, I would flip this around and write it as actual is less than predicted. So that way it's easier to interpret. Make sure the mouth, the alligator mouth, is facing the same guy. Anyway, I digress. Not that important. So let's get rid of all this. So actual greater than predicted. So that means we want to know how many points are above the line. That's what that's saying. If the dots are greater than the line, we want to know how many dots are above the line. So I'm going to circle all of them. 1, 2, 3, 4, 5, 6. Seems there are 6 points above the line. So I am going to go with answer choice C. And that is correct. Great, let's move on. Okay, this is module 2, question number 20. So whenever you see a system of equations, guys, and they're asking for an expression, we do what's called a clever combination. There's almost always some way to just put the equations together, either by addition or subtraction, and it'll just work out nicely. That's not a math thing, that's just an SAT thing. So do you guys notice how the 5y and the negative 5y, if we add those two equations, those guys will go away. So that's what we're going to do. So I'm going to add these two equations. These guys go away. I'm left with 0 equals 15x, and then minus 10. I'm going to add 10 to both sides, and I get 10 equals 15x, or 15x equals 10. And we want 30x, but we have 15x. So what we're going to do is we're going to multiply the entire equation by 2 so that we get 30x. So this is 30x is equal to 20. And that is the answer. So yeah, whenever you see a system of equations and the answer is an expression, so what I mean by that is not just x, so like 2x plus 3y or 5x minus 4y, this is probably what you have to do. There's probably some kind of shortcut that they've laid there hoping you figure it out. Okay, we could also do this one on Desmos very easily. So 5y equals 10x plus 11. negative 5y equals 5x minus 21. Okay, I'm going to zoom in. Okay, they touch here. We get 0.66666. Okay. Okay, that for x, that's 2/3. Now I'm going to do 30x, so 30 times 2/3. And I get 20. You kind of see this is maybe how they get you. If the fraction didn't come out so nicely and I wasn't able to quickly tell that that was 2/3, it would be a lot harder to get the answer using Desmos. So make sure you understand this idea, clever combinations. Great, let's move on. Okay, module 2, question number 22. Guys, this is a very, I don't want to say basic, but you get what I'm saying, introductory question ripped straight out of my Ottocento number 10 on area and volume scale factors. Please go watch that. I literally go over this exact question just with different numbers, so please go watch it. There's tons of important notes in there. They've been asking this a lot on the digital ACT. All right, so the way it's worded, I got two rectangles. They're similar. That's important. That tells me I can use scale factors. Okay, EFGH is the big one. So I'll just draw two rectangles. This is ABCD. This is EFGH. So they tell us that the length of each side of EFGH is 6 times the length of the corresponding side. So that is just a fancy way of telling us the length scale factor, which in my video I call capital K. The area scale factor is equal to K squared. In this case, 6 squared is equal to 36. So the area scale factor is equal to 36. That's something very important that they wanted you to realize. Okay, they tell us the area of the small guy, ABCD, is 54. So we're going to not divide, we're going to multiply by 36 because it's getting bigger. We're going from the small shape to the bigger shape. I go over this in the video. Please go watch that video if this is confusing you. Okay, so the area is 1944. That is answer choice D. And that is correct. Not much more I can say on this, guys. It's just something you probably didn't know that you got to know. Please go watch my Ottocento video on this. It goes over it in way more detail. Great. Okay, this is module 2, question number 25. Guys, I have a short which goes over this exact question. It's called Exponentials plus Time Units. Go check out my shorts tab. So again, you can just watch that video. I'll quickly go over here. So the concept is A is the initial value, B is the multiplier, T is time, and N is the interval. N is the interval. The concept they're testing you on here is that the interval has to match, the N has to match the units of T. So first thing we're going to do, go over this in the video, is we're going to rewrite this equation, putting the fraction on the bottom so that we can figure out what N is. When we move a fraction back and forth between the top and bottom, we have to reciprocate it. So the reciprocal of 6/4 is 4/6. So I'm going to rewrite it like that. We can now clearly see that N is equal to 4/6. The interval is equal to 4/6. 4/6 what, though? Well, the equation, the paragraph says that T is the years after 2003. So our interval is 4/6 years. But if you read the question, they don't want it in years. They want it in months. So we have to change it to months. Well, there's 12 months in a year. Let me write that down. 12 months equals 1 year. This is just, I guess, a unit conversion they expect you to know. And so I'm going to come over here and do 1 year on the bottom and 12 months on the top, one-step unit conversion. The units cancel. And now I can do 4/6 times 12, which is 8. So we get 8 months. And that is looking like answer choice A. Let's see if that's right. And it is. Yeah, so that's it. This is just something you got to know. Please go watch my series of shorts. There's 3 of them. There's 3 which go over in great detail how to work with these equations. Let me just show you something really quick. So kind of the idea. So do you see how in the question, I'm going to highlight this. It says increase by 4%. You might be wondering, like, how is that helpful? Or like, where did they get that from? So the percent change is equal to 100 times the multiplier minus 1. Percent multiplier minus 1. The multiplier is B, in this case 1.04. So you see them saying, how long is it going to take to increase by 4%? Well, the multiplier, you see, if we compute the percent change, it's a 4% increase. So it's just kind of a roundabout way of asking you the interval. Don't pay too much attention to that. I suppose they could make that like a wrench to try to trip you up, but most of the time these questions are straight up just asking you for the interval. Just pay very close attention to the units because you will have to convert the units. Remember, the units of the interval match the units of t in whatever equation you're in. They have to match. Great, let's move on. Okay, this is module 2, question number 26. So I did this exact question with different numbers, I think on one of my problem set days and also in the Skills Insights tool videos. So hopefully if you've been watching my videos, this isn't your first time seeing this question. Essentially, we have a circle at -1, 1. And then there's a point on the circle, 5, -4. I'm going to try to, okay, so I'm going to go right and then down. And then there's a line that goes through it. And it's tangent to the circle, so that means it grazes it at just that one point. So the concept here that they expect you to know, there's just something on the SAT. I believe it's called radius tangent theorem. So the radius and the tangent line are perpendicular. So what we're going to do is the radius is formed by these 2 points, -1, 1 and 5, -4. So we're going to calculate the slope, find the perpendicular slope, and then use that to find the equation of the line. So we'll do that. Okay, so let's see, slope formula, y2 minus y1 over x2 minus x1. So that's -4 minus 1 over 5 minus -1. And that's -4 minus 1 is -5. And 5 minus -1, that's 6. So the slope is -5/6. And now I am going to use, how about point slope? So the point that's on the line is just this one. Oh, before we do that, we have to find the perpendicular slope. So the perpendicular slope, perpendicular slopes are opposite reciprocals. So you flip it, raise it to the -1 power, flip it, and then change the sign. So instead of -5/6, it's going to be 6/5, but positive. We have to change the sign. So that's another concept you got to know. So that's like 2 concepts they're testing you on. So the perpendicular slope is 6/5. It goes through 5, -4. So that's y minus -4 plus 4 equals 6/5 x minus 5. Okay, so that's the equation of the line. And really, I just need to look which of these points goes through it. So I guess I have to guess and check. I don't think there really is another way. So why don't I plug in 0? So if I plug in 0, I get 6/5. I get -6 on the right side, and then 6/5 plus 4, whatever that is, 5.2. -6 does not equal 5.2. It's not that one. Okay. Y plus 4. 7 plus 4. The answer is B, 11. 6/5 times 4 minus 5. 11, -1.2. No, that's not right. Okay, let's try 2 plus 4. That's 6. 6/5, 10 minus 5. That's also 6. Okay, so for answer choice C, I get 6 equals 6. So I think it's that one. And that is correct. Okay. Let's see if we can... I don't know how much doing this on Desmos would really help. I mean, once you figure out the slope, I guess you could regress it, but that would only save like one step of work. I'm going to see if I can make the picture just to kind of drive this home. So let me just do that. Give me 1 second. Okay, guys, this isn't perfect, and you wouldn't have to do this anyway, but I don't know, just to kind of... So you can kind of visualize what's going on. So I labeled the center C. I labeled the point of tangency capital T. I calculated the radius by doing the distance between them. And then I typed the equation of the circle. I drew the radius using a polygon command. That's not important. And more importantly, though, at the end, I drew what I think the equation of the line is. And you can kind of see, oh, with the radius on the picture, you see, oh, that looks perpendicular. I bet that equation is right. Now, the only thing I did differently was I used function notation, and I moved the 4 to the other side. So I subtracted 4 from both sides. That's called modified point slope. The reason I did that was so that I could quickly guess and check. So see, look, I was like, when x is 0, y is -10. Look at answer choice A. Okay, that's wrong. When x is 4, y is -5.2. Okay, that's wrong. When x is 10, y is 2. Okay, that one's right. And when x is 11, y is 3.2. That one's wrong. So you see, even if you didn't have to do that, or if it wasn't super helpful, it's really good for kind of just getting an image in front of you and checking your work. At least when you're practicing. Great, let's move on. Okay, that completes the lesson. Please like and subscribe for more digital SAT math content. If you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.